molecular formula. So now we're going to look at the process by which you figure out the molecular formula given an empirical formula. Problem, H4O3 of 176 grams, what is its molecular formula? So we have the empirical formula, we have the molar mass of the molecular formula, but then we need to figure out what that molecular formula is. So let's write down the information we have. So we have the molecular formula is what we're trying to find. So we'll write, I'm going to abbreviate. Let's write molecular formula MF. And so that's our unknown. And the empirical formula is given to us as C3H4O3. So the empirical formula is C3H4O3. Now we have the molar mass. So the molar mass, I'll abbreviate that MM. So the molar mass is 176.12 grams. Now, in order to get a relationship between the molecular formula and the empirical formula, we'll need to find something called the empirical formula mass. And so that's basically the molar mass of the empirical formula. So let's figure out what that would be. So the empirical formula mass, I'll abbreviate that EFM. So that we can figure out by adding up the molar mass of the empirical formula. So carbon is 12.01 in the periodic table, times 3, because there are 3 carbons, plus 4 times 1.01 for hydrogen, plus 3 times 16 for oxygen. So we add that up, and we get 88.07 grams per mole, or I'll just call it grams. And so that's something called the empirical formula mass, 88.07 grams. So in order to figure out the molecular formula from the empirical formula, we can use the relationship between the formula mass and the molar mass. So we have the molar mass, which is 176. So the relationship between the molar mass and the empirical formula mass, that is going to be the relationship between the molecular formula and the empirical formula. So let's put in the numbers here. So the molecular formula we'll figure out by figuring out this ratio between the molar mass and the empirical formula mass. The molar mass is 176.12 grams, and the empirical formula mass is 88.07 grams. So if we do 176.12 by 88.07, we get the integer. So let's do that. So 16.12 divided by 88.07. So we get this number 1, which rounds to the integer 2. So there's a relationship 2. So therefore, we know that the molecular formula is twice as much as the empirical formula. So we can take this relationship, let's ignore this right here. Let's take our empirical formula, C3H4 H4O2, and let's multiply everything by 2. Multiply all those numbers by 2. And as a result, we will get the molecular formula. So this is the empirical formula. Multiply everything by 2. And now we get the molecular formula, CH8O4. So that's how we can figure out the molecular formula from the empirical formula. So this is the molecular or true. Now sometimes we might have problems where we are combining what we did yesterday with empirical formula calculations with a molecular formula problem. Let's look at this one, number 2. The insecticide lindane has a percent composition of 24.78% carbon, 2.08% hydrogen, and 73.1% chlorine. If its molar mass is about 291 grams per mole, what is the molecular formula? So we have the percent for each element, and we have the mole. This time we don't, but we can use this information here to figure out the, kind of like we did yesterday. We're going to go through a process kind of like this, figure out that empirical formula, and then from there we can follow up with the process that we just saw. All right, so first we have 24.78% carbon. We have 2.0% hydrogen. And we have 73.14% chlorine. Now, if we consider that these are percentages out of 100 or parts per 100, we can consider these as the number of grams in 100 grams. So this would be the same thing as 24.78 grams of carbon. This one is 2.08 grams of hydrogen. And then this one is 73.14 grams of chlorine. So now we convert that to moles so that we can compare the relative amount of moles for each element. So we'll need to divide by the molar mass for each one. 12.01 for carbon, 1.01 grams for hydrogen, and 35.45 grams for chlorine. So this comes out to 2.06 moles carbon, 2.06 moles of hydrogen, and 2.6 moles of chlorine. Well, that's convenient. It's the same number for each one. So our empirical formula is going to 1-to-1 ratio, because as we saw yesterday, we'll be dividing the number of moles by the smallest number, which is, and it's the same for all of them. So for all of them, it's 2.06 over 2.06, 2.06 over 2.06, 2.06 over 2.06. So just ones. CHCl is the empirical formula. So that is the empirical formula. So if we have the molar mass given us, which we do, we can figure out the molecular formula. So let's figure this empirical formula mass. So we have the molar mass of carbon, which is 12.1, plus hydrogen 1.01, plus chlorine 35.5. So the empirical formula mass is 0.47 grams. Now the molecular formula weight, or the molar mass, so molecular formula molar mass, or weight, molecular formula weight, the problem tells us is 291 grams per mole. We'll just write 291 grams. So we divide these two things, 48. If we find the small integer relationship between those, and we need to do it in this order. We need to do molecular formula weight over the empirical formula mass. So 291 grams divided by 48.47 grams. So when we do that, we get the integer, it's about equal to 6. Let's look at the exact calculation. 291 divided by 48.47. So it's 6. The number is 6. So the ratio is 6. That tells us the empirical formula to the molecular formula. So the molecular formula, we need to multiply everything by 6. Times 6, times 6, times 6. So our final answer then is C6, H6, Cl6. That is the molecular formula.